so for this problem, we are given the derivative of f. So we are looking at derivative. Okay, so this is the graph of my derivative. And we want to find where f has a relative max. So if you remember, f has a relative max when 1, the derivative is equal to 0, and 2, the derivative changes sign from positive to negative. Okay, so what we're doing is we're looking for the zeros. Since this is my derivative, we're looking at the zeros. We have a total of 4 zeros. Okay, I am not going to include my endpoint because my endpoint is not a relative max for min. So since these are my zeros where the derivative is equal to 0, I need to see where the y value of the derivative changes from positive to negative. Right, so here's positive, the y values are negative, y values are positive, y values are negative. So I'm looking at x equals negative 3 because it changes from, the derivative changes from positive to negative, and at x equals 4 because the derivative changes from positive to negative. So at x equals negative 3 and x equals 4, f has a relative maximum because the derivative is equal to 0 at those points and the derivative changes sign from positive to negative at those points. The second problem says for all values of x, find where it's a point of inflection. So find where f has a point of inflection. So there's a point of inflection when the second derivative of f is equal to 0 and the second derivative changes sign. Since we are looking at the graph of the derivative, okay, we're looking to see where the second derivative is equal to 0. Since this is the graph of the derivative, we are looking for horizontal tangents or where the second derivative does not exist. So that occurs in 3 places: at x equals negative 4, at x equals negative 1, and at x equals 2. Okay. So we just need to make sure that it changes signs. It changes signs because see how I'm going from increasing to decreasing, decreasing to increasing, increasing to decreasing. So at x equals negative 4, x equals negative 1, and at x equals 2, there are points of inflections because the second derivative is equal to 0 and the second derivative changes signs. Okay, the last thing is asking when the graph is concave up. So again, we're looking at the derivative. This graph of f is concave up when the second derivative is greater than 0. So since we're looking at the derivative, we're looking to see where I'm increasing. So I'm increasing here and I'm increasing there. So at what intervals is it the f concave up? From negative 5 to negative 4 and from negative 1 to 2.